Well, of course, I've got no idea where the clipboard is. Ugh. So what have we here? This set I bought, and it's my favourite Cybernet model of all time, which is the Harvard 420M. So you get the same chassis you get in the York 863, the Rotel 240, the Binatone 5-star. You get the bigger speaker like you get in the Binatone 5-star. You get the extra receive circuit like you get in those top sets, but there's less fussy knobs. So really my favourite set. And you can sometimes pick these up for less than you would a York 863 because it's Harvard. They think Harvard good buddy, they're not very good. Well, the Harvard 420 is one of those outstanding sets. So I bought this, and will it be any good? In fact, it's got a label on there, probably says doesn't work, but somebody took it off before selling it. So we're somewhere around September. Let's guess at the 6th. And it's a Harvard 420M 11104822. They were $89.99. And if we get this going, my fluorescent light has just failed. That's going to be good, isn't it? We're going to have a flashing... I better open this up. So when we sell this, I won't do the case up. I'll give somebody else that pleasure. So you can see we've got the 3.5-inch speaker in this rather than the usual 3-inch speaker. Got the extra filter circuit there, which you don't have on the lower models. And I can't see any silliness, any shenanigans, or any oozing capacitors. And at first glance, I can't even see any broken cores. So I've got an Altai standard replacement mic here. No, I'll tell you what, before we do that, we'll use my standard replacement mic rather than the one that I intend it to go out with. So we'll use our standard one, which we know how it sounds and how it works. This comes with a brand new power lead. And we'll do all the testing with this power lead, so the voltages applied and any losses are built into the readings that we take as usual. Right, there we are. Well, we have a dead set. There could be lots of reasons for that. So I'm going to unplug the power and check we've actually got power on here. And the problem I've got with this is that the prods on here are not long enough to reach the conductors. So we'll just use this analog meter we're using on the Pi Westminster with much less safe prods, which will suit me. and we've got no power. And that's because we've got no fuse. Well, that sorted that out, didn't it? That lead is a new lead. It's not something that comes with the radio. Wouldn't it be fun if there was still no power? No, that's if I've got power. May as well leave the meter out because we're going to have to do the VCO. Right, we're lit up now, and I'm going to connect the test instrument to extension speaker. We're going to connect the extension speaker we have mounted on the wall to use as a PA speaker. So there we are, channel 9 off, take it to channel 20. Yeah. Right, we'll start with PA. Testing 1 2, testing 1 2, testing 1 2 1 2 1 2 1. Right. So we've got our earth on there. We want to select channel 40. There we go. So put picture on the main meter, not that we're looking at that at the moment, and we want 4 volts on the far side of resistor 4. We haven't got 4 volts, we've got 4.9. So that needs addressing. We're going to end up with channels dropping off if they haven't already. And on transmit, we also want 4 volts. Might help if I get the aerial plug in and I don't press transmit without an aerial. It is transmitting. Looks like it's doing 3 watts. Got 3.48, so I just need to pop that up a fraction with the trimmer capacitor. We are started to have these trimmer capacitors play up. There we go. So it was 4.8 plus, I can't remember, so it's 4 plus 4 now. Meter, PA works, sockets work, meter lamp works. To start, so we've got something to work with, and I should be able to put the multimeter away. So I'll start by putting it on frequency. The test gear's been on all day. We need to put it on channel 20. And it's 27 78125. That is so off frequency. It's like between channel. I'm just going to take the lid off just to make sure there's no shenanigans going on. Looks like we've got a Duff reference crystal if that's the case. Just go to channel 1 to make sure, it should be 60125 59 something or other. Channel 40 should be 99125 and it's 98. Yes, so everything's out of kilter, so that's something I thought I'd better just check in case it wasn't selecting channel 20. We've got to have this lid off anyway. I'll run those through the dishwasher tomorrow. That's absolutely fine. That's got no shenanigans. Let's put picture in picture back. Oh, we are still on the frequency counter. I'm not expecting this to come into frequency because it's so far out. Let's see what happens. No, absolutely not. Right, while the soldering iron warms up, we'll start on the transmitter adjustments. Don't like wasting time. Making sure we're on channel 20, so we're in the centre of the band. And oh, at the moment we've got, before I do any adjustments, we've got 3 watts exactly on channel 20. Channel 40, got 3 watts. Channel 1, we've got 3 watts, so it's really well balanced. On low power, we've got 70 milliwatts, and we are drawing what current? On full power, we're drawing 966 milliamps. For what it's worth on this test set, let's see what the deviation is. Wow, at 1.5. That's probably not true. So we'll do the tune up. Step checking once again, we're on channel 20. So the centre of the peak is there. Slight adjustment there. Centre of the peak there. I'll have to go to the other scale now. Is there. So I say we need to get this above 4.4 watts to balance it, if it'll do that, and then we'll pop it back down to 4. I say back down to 4, we'll pop it to 4. So our first adjustment has brought it to 4.5. I have to be quick with this because the transmitter can't support this kind of current. This has never been fiddled with. It's as it came out of the factory as far as this goes, and it's just done 5 watts. Just check that again. So I say never ever leave it like that. Legality aside, I know we're allowed 4 watts. 5 watts doesn't make you get out any better. What is important is it will melt the coils if you leave it like that. So you need to turn this clockwise for 4.4 watts. The service manual says turn the green one anti-clockwise for 3.8 watts. But we are going to set it for 4 watts because we're allowed 4 watts. There we go. Let's see what we've got on channel 40. We have 4 watts. And on channel 1 we've got 4 watts, so I've balanced that as well as it was before I fiddled with it. 4 watts, 4 watts, 4 watts. low power is now exactly as bad as it was. Let's get the service hole. Sometimes these presets have failed if they've used low power a lot, and sometimes they just need a spray because they've got dirt after 43 years. So waggle that around. That's as smooth as anything, so I'm happy it's going to stay put at 400 milliwatts. Right, current consumption on full power 1.125. So back to the frequency 27.78567 78567. So what we need to do is put another crystal, can't speak, another crystal in this. Okay, so swap the crystal. Must remember to throw away the other one. So that's what we've taken out. I've put a second-hand one in. I've got a new one here, but it wouldn't go. We find this a lot with the new crystals, that they won't go. I keep buying them, but this is the one which has gone in, is recovered from something. And you will see, although the set's going to have to cool down, the crystal's going to have to cool down from soldering for me to get it accurately, we can just get it roughly on for now. You can see it's higher than, which is great. So 79125, tried a couple of others and they were too low. One of them would have been acceptable, 105. So put it as if it's correct, that'll do. 279125. I'll have to get on with this before the fluorescent bench light fails. Good. Anyway, now we know why they sold the set. I'll do the deviation and then we're kind of done with the transmitter. So I'm going to connect to the test set behind me, the Quartz Lock 282A, whose deviation meter I trust, and we'll want that preset to its central position, which is the AGCE fiddly backy thing. I've now discovered we haven't got this test set on, so I'm going to have to take a break for 5 minutes. Whilst it warms up and gives me a reasonable thing. So I'll come back. Right, I'm back. Let's see what I've got. One, it's two. Wallow, wallow. That's 2.5 peak. Wallow. It says it's 2, so it is lying today. So it was 2 as it was. It's now 2.2 to 2.5 peak. Untransmit the meter. It's 4 now. Never did know what it was before. Good. We'll move on to receive. What was 0.3 of a microvolt, which you could hear, We had all those nearly New York 863s, didn't we? So let's see if we've got anything as good. So at the moment we've got 0.3 microvolts. Let's put the SINAD meter on so you can actually see. That's the wrong way. For 10 dB, it's 0.24. And for, it's 0.7 for 20. Squelch to full. So I want it to be 100 microvolts for the squelch to open when it's in full squelch position. So that's S9 equivalent. 3, 10, 30, 100. That's fine. And threshold is 0.42. S meter, so we'll put S9, which is 100 microvolts on the signal generator, EMF mode, and at the moment it's 8. So to get S9 we're needing to put on it's just over 300 millivolts, so it's a bit tight that. Right, so we'll do a tune on the receiver and we're going to start with 100 microvolts and we're going to look at the detector. So this FM detector, and we need to maximise the recovered audio. If we don't do that, I'll just get a decent trace on this oscilloscope by turning the volume up. If we don't do this, it'll be either garbled one direction, or if it's the other direction, it will be quiet on recovered audio. So let's see. So it was slightly out. Right, we'll do the SINAD now and get all the receiver tuned. Back to the SINAD meter. We'll turn the attenuator till we get... I'm going to have to go down another level. About 5 dB. So we're not saturating the receiver. Let's see whether this one, which is hidden, needs any adjustment. It's quite a bit. So we back off the attenuator. Next one. Slight amount on that. Next one. Slight amount on that, oh, a little tiny bit, all adds up to something. Now I want a bigger signal to do these IF ones, IF meaning intermediate frequency. Slight adjustment on that one. Nothing, that was spot on. And that was spot on. So now we'll get a new reading off the SINAD meter for what we've accomplished. Just check it's not one of these which we touch and it gets better. It's 0.2. It's another really good set. Go down another scale, but we're on this overlap. Yeah, it's still 0.2 because of my being between scales. And for 20 dB, we've got 0.45. Now this will have affected the squelch. Squelch to full. put the attenuator back up. So 100 microvolts, remember I want it to come in 3, 10, 30, 100, it still does, so that's still fine. Turn the squelch down, signal generator to standby, set squelch to threshold, signal generator back on, parks at 0.3 of a microvolt, and we've got 0.53. So we want the S meter to read 100 microvolts, and I'm using EMF mode, as I keep saying, which is harder to achieve than PD, which is potential difference. We need to adjust that meter so I get an S9. Like that. If we needed to adjust the squelch, it would have been that preset there, but we don't. Wow, another really good set. I'm going to go back now on to transmit, because after 10 minutes, of course, the crystal will have cooled down from soldering. Oh, we've got the frequency counter up, 2779. Yeah, it needs to come up. There we go. We are done. So I'm going to clean the case a bit, because it's one we're going to sell. We'll just put it on the aerial before we finish the video. Test this. Turn this test gear off. All done. So Duff Crystal is making it go in between channels. Put it on the aerial. It sounds like silly noise time. So there's no point going 19 Roger, is there? So that's why you can't use 19. Doesn't look like you can use it anywhere, does it? It doesn't matter what road trip it goes on. There's people messing about or on burners with their illegal silliness. So there we are, a really nice Harvard 420M that's delivering a full 4 watt output and 0.2 of a microvolt, which is well improvement from what I think it's 0.7 is supposed to be 12 dB on these, so it's a really good set. So that matches some of those really good York 863s that we did the other day for the other customer. So there we are. So we'll put this together with some cleaned cases and we'll do an on-the-air test tomorrow. Thanks for watching. One of my favourite sets, the Harvard 420M.